Hi theory students. Today we're going to be talking about ordered pitch segments and serialism. In this first part, we'll introduce the concept of ordered pitch segments and talk about the basic operations with them. An ordered pitch segment is a group of pitches where the order in which they appear is maintained. We're already familiar with this concept with much of the music we've studied when we talk about pitch motives. So remember, when we talk about a set, we're referring to an unordered collection of pitches. In other words, one in which the pitches in the set could be used in any order that the composer wishes. When we talk about a segment, we're referring to an ordered set of pitches where they're introduced in a particular way. While we have standard ways of listing pitches in the set, like normal order or prime form, how they're actually used in a piece may vary. With the segment, as I said, the pitches are used in a particular order. So a reminder of some of our notation. When we have a set, we use curly brackets to indicate that it's an unordered pitch set. When we have a prime form of that set class, we'll use the square brackets. So 056 might be what actually happens in a piece. 016 would be the prime form that allows us to look it up and identify that as set class 3-5. When we use angled brackets like this, we're indicating that it's a segment or an ordered pitch set. So for example, 7, E, 9 is A, and 6 is F sharp. And for a segment, the first full version of it that we get in a piece we'll call the prime. Understand this is different than the prime form of unordered set classes, but it's the same word, so be careful that you're aware of whether we're talking about a segment that's being used in a piece and the prime is the first full version of it, or whether we're just talking about the prime form of a set class so that we could look it up. So here are the basic operations or the ways that pitch class segments can be moved or manipulated. Some of these are very familiar to you already. Transposition is moving each pitch by the same interval. We do this by adding the same number, mod 12, to each pitch. So in other words, going clockwise around the clock. We can also transpose down by going counterclockwise, but if we're just talking about mod 12 arithmetic, we can go up 8 or down 4. So generally when we state these in positive terms, we mean that we're just going clockwise. Inversion is when each interval from pitch to pitch moves the same amount, but in the opposite direction. We do this by reversing the signs of each interval. So let's look at an example. In the book, they have a piece by John Tavener, a modern composer, who wrote a piece called The Lamb, and without the lyrics, the first phrase in the soprano goes like this. That is then answered in the alto part singing along with the soprano, but this alto part goes in the opposite direction. So if you think of these intervals as +4, -2, -3, and +1, now this goes -4, +2, +3, and -1. So instead of this, we get or together when that segment and its inversion are heard at the same time. When we talk about a retrograde, that's when the segment is heard with the pitches in reverse order. We simply use the pitches of the prime form, but we'll use the last pitch first and go all the way till the first pitch is heard last. In the Tavener piece, we find out that what we heard in the opening was just a fragment of the theme, and that the full ordered pitch segment is this. We very quickly hear that in reverse order. And finally, there's the retrograde inversion, which does both operations. We do the inversion first, and then we perform the retrograde. Going back to this Tavener example, for the prime form in the soprano, the retrograde is heard. Along with that, the alto line has the inversion of the soprano line. That's the second line that I've written here. I'm sorry. There we go. And now the retrograde inversion does the inversion form backwards. So now the labels. T7P means that we transpose the prime form that starts with 0 by pitch class interval 7. Remember that the pitch class interval is the one that goes clockwise around the clock. T7I means invert the prime form first, and remember, we invert pitches by adding them up to 12. So 2 becomes 10, 9 becomes 3, etc. And then we'll transpose by pitch class interval 7. T7R means transpose the prime form by 7 and then reverse the order of pitches. And T7RI means invert first, transpose by pitch class interval 7, and then reverse the pitches. Let me show you an example. So for our prime form, we originally wrote at least 4 of the pitches, 7, E, 9, and 6. This is the T7 form of the prime form, which would be 0, 4, 2, and 11. So now T7I means take this prime form, and when you invert it, it becomes 0, 8, 10, and 1, and then you transpose by 7. So now that the inversion T7I becomes 7, 3, 5, and 8. T7R means that you take the T7 form here and you reverse it. 6, 9, E, 7. T7RI means that you take the T7 inversion form and you reverse that. 8, 5, 3, 7. We can use a short form for each of these operations. When we talk about P7, we mean T7P. I7 is T7I. R7 is T7R. And RI7 is T7RI. Notice that for the R and the RI forms, the number is the last pitch of the segment, not the first. So here, the R form has 7 last. The transposed P form has 7 first. The RI form has 7 last. The regular T7 inversion has 7 first. We use that labeling so that we can understand the relationship between a prime form and its own retrograde, or an inversion form and its own retrograde. So remember that anything with an R in it, the transposition number will be the last pitch we have, not the first one. Another example. So if this is a P0 form, 0, 3, 10, 9, 1, 2, the P7 form transposes each of these pitches by 7. The I7 form takes the inversion first, so 0 becomes 0, 3 becomes 9, T becomes 2, 9 becomes 3, 1 becomes 11, 2 becomes 10, and then I'll transpose that by 7. We get that. The R7 form takes the P7 form and reverses it. And I typed that incorrectly. No, 7T5, 4, 8, 9. That's right. And then the RI form takes this inversion form and reverses it. We'll be doing more with this, especially as we look at 12-tone music, but that's for the next video. That's all for today.